Good afternoon, my YouTube viewers. Crystal here. I decided I wanted to make you another video. Now, I have finished the videos that I was making on sklearn's toy dataset, and then I made a video using a heat map with Amy's house prices, which is also a Kaggle competition. And just recently, I went on to Kaggle, and Kaggle has their February 2021 competition. So I decided that this morning I would do the February 2021 competition. So what I did was, it would take too long for me to sit there and do the competition on the video because I would be like making mistakes and trying out new models and things like that. So I've done the competition already, but what I'm going to do is I'm going to go ahead and do a code review. And when I do the code review, I'll go through with you everything that I did. So I submitted the competition and I got a score of 86.78%. And I thought, oh, that's horrible, because the way that they're doing the scores is they're doing the scores on root mean squared error, or they're doing the scores on a different type of error. So it's not an accuracy. So whenever I jump to the leaderboard, you can see that the highest score is 84.19%. So I'm only about 2.5 points worse than the best score. But even so, I'll take you through the leaderboard, and and then you can see what we've done. So the first thing I did was, this was my submissions. It said you may select up to 2 submissions to be used to count towards your final leaderboard. So what I'm going to do is I'm not going to work on this anymore. So I'm going to tick onto the box that says use for the final score, because I'm not going to try it anymore. And the reason why is because I tried out several models before I used the linear regression model, and it was really hard work finding a good model. I tried random forest, and it sort of made the computer crash. I tried a HIST gradient boosting regressor. I wasn't really thrilled with that. I tried Gaussian. I tried lots of radius neighbors, and because this is a data set of a lot of examples, it just crashed the computer. And because it crashed the computer, I just thought, well, I'm just going to try out linear regression and see what happens. And I just decided I'm going to leave it at that. And so I'm only 2.5 points worse than the best score. So we're going to go ahead and go through the code review. So here we are in the code review. First thing I'm going to do is I'm going to do sharing, and I'm going to make it public. So anybody who wants to look at my code can look at my code now. I've got a short little problem statement. The short little problem statement says the data set is used for this competition is synthetic, but based on a real data set and generated using a CT-GAN. The original data set deals with predicting the amount of an insurance claim. Although the features are anonymized, they have properties relating to real-world features. So that's your problem statement. So it's a synthetic problem statement. And we're going to go through this code reviews. The first thing that I did was I imported my libraries. I did all of this in Kaggle. I didn't do any of it in Google Colab. It was all done in Kaggle. So I imported my libraries. I imported NumPy, which is used for linear algebra. Imported Pandas, which is for data processing, CSV file IO, etc. I imported Matplotlib, which is a graphics library, and Seaborn, which is also a graphics library. So the first thing we want to do is we want to load our CSV files, and since this program was written entirely in Kaggle, I had to use the Kaggle directory, so you can see the Kaggle directory here. And then I want to load my data set. I loaded the train, test, and sample. This is your train file. You see it has 300,000 rows of data and 26 columns. And the final row is your target. Okay. This is our train data set. It had 200,000 rows of data and 25 columns because it doesn't have a target column, because that's just for your train file. Then we check our sample. This is what Kaggle wants to see when I submitted it. They want to see the 200,000 ID numbers and the target. And you'll notice that I'll just show you something unusual here. This is your ID numbers for train 1, 2, 3, 4, 6. And these are your ID number for test 0, 5, 15, 16, 17. So the ID numbers for these two files are not sequential. It's a total of 500,000 rows of data. And with this 500,000 rows of data, they have some of the rows of data in the train file and some of the rows of data in the test file. In addition to that, so that's what we've done. And so this is what, when we submit the predictions to Kaggle, they want to see the ID number and they want to see the target. So now we check train info. So you've got your ID, which is an integer, and then you've got 10 categorical columns, and then the rest of the columns are float. The same with the test file. And you notice that on the train file, the last column is target, but we don't have a target on the test file. Now what we're going to do is we're going to analyze the target. So we do train target describe, and so we've described our target, and that gives you the mean, standard deviation, minimum, 25%, 50%, 75%, and max. And now what we do is we put this on a disk plot, and so you can see where the target fits into this graph. Now what we're going to do is we're going to do a heat map of the train data set. And what's really interesting, if you looked at my previous video where I was talking about a heat map, what is very interesting about this data set is none of the heat maps have a strong correlation to the target. So very few of the heat maps, very few of the the variables, the independent variables, actually have a strong correlation to the target. Because if you look here, here's your target, and here are all of your columns. And every single one of them are below 0. So every single column, every single numeric column is below 0. So it has very weak correlation anyway. I mean, I'm not sure exactly how they decide which columns correlate to the target, but they do. And maybe one day I'll research that. I'll say how to determine which columns correlate to target. That will be a good exercise. But none of them correlate. So now what we want to do is we want to define our y. So y equals target train, or train target, and you can see, there you go, there's your y. Now what we want to do is we want to combine train and test. Xtote equals train dot drop target axis equals 1 append text. And you can see Xtote here. So we've got a total of 500,000 rows at 25 columns. Now what we're going to do is we're going to check Xtote for any null values. And there's not any null values that need to be imputed, so that's good. And now what we're going to do is we are going to ordinal encode the categorical columns. So we ordinal encode the columns to get only the values, and then we reshape them. And now what we've done is after we have ordinal encoded the categorical columns, you can see that now all of the categorical columns are actually a number. Because if we go back here, before that, they're letters. And the models won't work with categorical columns. It all has to be converted to a number. So now what we do, after we've ordinal encoded our categorical columns, what we want to do is we want to drop the ID because we don't really need it. So we've dropped our ID. So now we only have 24 columns, and that's what's going to be used to make predictions. Now what we're going to do is we're going to normalize Xtote to convert all the values in the data set to a value between 0 and 1. Now what we want to do is we want to split up Xtote for training and testing. So rows equals len train, xtrain equals Xtote colon rows, xtest equals Xtote rows colon. So now you can see xtrain, it's again only 300,000 rows, and you can see xtest, which is 200,000 rows. So now what we do is we're going to split our xtrain for training and validation, and we're going to use train test split from xklearn. So xtrain xval, ytrain yval equals train test split xtrain y, test size equals 0.05, random state equals 1. So I decided to have a small validation as possible. So now what we want to do is we define our model. Now I tried several models. I tried hist gradient boosting regressor. I tried Poisson. I tried Tweety. I tried Elastinet. I tried Random Forest. The Random Forest and some others crashed the system. And the reason why it crashed the system is because there were so many rows of data to make predictions on. And finally, out of exasperation, I just thought, well, I'm going to use linear regression, and I'm just going to put it in and see what happens. Just put it in and see what happens. Because by this time, I was fed up because, you know, I try to do one blog post a day because I need to do the blog post to make a little bit of money. So model equals linear regression, fit X train, Y train, print model score X train, Y train, and we got only a 4% accuracy. And I just decided, well, I'm going to plug this into the system anyway. I'm going to submit these scores anyway and just accept what I get because, you know, I can't spend too much time on it. And all of the models that I was hoping would work wouldn't work. And we know that's because the columns have a very low correlation to the target. So now what we do is we predict on our validation set, ypred equals model predict xval, and then we print model score xval yval, and again we have a 4.4% accuracy, so that's very low. We checked our RMSE, which is the mean squared error, and our RMSE is 0.8658, which isn't too bad. I mean, I've seen RMSEs a lot higher than that. And now what we do is we put it on a data frame so you can compare your predicted values against your actual values. And then now what we're going to do is we're going to make a graph. So the blue line is your X val and the red dots are your ypred or your predictions. So you can see that all the predictions were around 7. Now what we're going to do is we're going to predict on the test set and submit. So final labels equals model predict X test. And then here's your final labels. They're all 7s as well. And then we put the final result into a data frame. And we created a CSV file called submission. Got a message saying your submission was successfully saved. And then we upload the submission onto submission equals PD read CSV. So again, we're uploading the submission. So that's our actual submission that I submitted to Kaggle. So here's your sample submission. It's a 0.5. And then now here's the actual submission, which everything is a 7 point something. But I'm not going to resubmit it because I've already submitted it just the once. And then if I do resubmit it, then the way Kaggle works is Kaggle is going to put it on a different page and you won't be able to see the page anyway. And the reason why that is because the screen recorder that I have only allows me to record one tab at a time. So that's it. That concludes this code review. I hope you like the code review. If you like my videos and you want to keep receiving videos, then please like, subscribe, and share. And then if you want to receive a notification whenever I have made a video, then please tap on the bell button next to the subscribe button. And what that will do is every time I make a video, you will be notified that I've made a video. And if you like the work I do and want to support me, I've got my email address to my PayPal account in the description box down below. So as I conclude this video, thank you so much for watching my video, and I look forward to making new videos for you in the future.